All right, so now we're going to move to the next topic. The next topic is fluoride. And so I don't know if I went through this just briefly that, yeah, I got teased about my teeth. I said, okay, I'm going to buy one of those toothpastes. I don't usually brush my teeth with anything. Sometimes I'll brush them with the bacteria can hide in. You know, if I just don't eat any sweets or soda pop or anything acidic, so it's not a problem. I rinse my teeth off with water, little interdental brushes. Always do it at night, because at night when you're asleep, your saliva decreases and you're more prone to getting cavities. So you don't want to leave food in your teeth at night. Okay. So anyways, when I saw all these toothpastes, they all had this little signs on the package that said fluoride anti-cavity toothpaste. And to me, that was like writing, step right up and poison yourself, you dummy. Okay, I couldn't believe it. I mean, this information's been around for a long time, all the problems with fluoride. And I actually almost made me feel sad. I'm like, oh my God, if 99% of the toothpaste on display advertises fluoride on the front cover, that means almost no one knows the problems with this stuff. Okay, and so to understand it, you got to go back and learn a little history. Here's a nice painting of Cicero, greatest of all Romans. Okay, and here's what Cicero said: to not know what happened before you were born is to forever remain a child. Okay, that's even called a Ciceronian sentence there to put the conclusion right at the end, and it has more dramatic impact, the professorial style. Okay, Aristotle, he says, if you want to understand something, then study how it was made, where it comes from. Okay, so let's look at fluoride. Fluoride is a halogen. So halo means salt, gen means to produce. They're the salt producing elements. And what's unique about it is it has an incomplete outer orbital of electrons. It only has 7 electrons. So here, this red electron here is unpaired. So when you have an unpaired electron in the outer orbital, it really wants to grab another electron, because to get 8 electrons in this outer orbital is called to complete one's octet, and that makes it more stable. And so fluoride is very aggressive at grabbing electrons. So here's fluoride in the periodic table of elements. And of all the elements, out of every single one of them, fluoride has the highest electronegativity. En is electronegativity. So it's right here, and it is super high. Right next to it is oxygen, which, of course, in electron transport within the mitochondria is the ultimate electron acceptor. So it has very high electronegativity too, but fluoride even more so. This vertical column of elements are the halogens. So halo, salt, gens producing, salt producing. And every single one of them is sort of toxic to bacteria. So the halogens kill stuff, okay? And that should tell you something. Fluoride, chlorine, we sanitize pool water and drinking water with chloride, okay? Bromine is also used to sanitize pools. We used to do surgical preps with iodine, okay? So these are all toxic. I realize that iodine is incorporated in the thyroid hormone, and chlorine is also in our bodies. But just in general, that's important to remember. Halogens have a strong tendency to toxicity. And because of this high electronegativity, they really want to grab an electron. And when they grab an electron, fluoride grabs it. It does not give it back. One definition of a pathogenic chemical is that it steals electrons. It steals electrons and it does not give them back. It's just a thief. It is not a giver. It is only a taker. So that's important to know about fluoride. Okay, so fluoride has been used for rat poison, for insecticides. It's put into wood as a preservative. So you tell me, how are you going to take rat poison, insecticide, and wood preservative and use it to promote human health? Okay, something that kills rats, insects, and fungi, is that going to be good for health? I don't think so. It was well known up until 1940 as a poison. The aluminum industry had a problem with its waste product of fluoride, as did the phosphate fertilizer companies. So they were able to maneuver a study showing that fluoride had a benefit, they claimed, for teeth. And then they had, they got millions and millions of dollars. The pathogenic chemical is that it steals, or had a benefit, they claimed, for teeth. And then they had, they got, oops, as someone had played back, it was playing back. Okay. Anyways, I'll continue here at the next slide. Glucose goes into the cell, and then it goes through glycolysis in the cytoplasm. Then it goes into the mitochondria here. The center of the mitochondria is called the mitochondrial matrix. This is the inner mitochondrial membrane. Here's the outer mitochondrial membrane. This right here is the intramembranous space. That's going to be relevant. Along the inner mitochondrial membrane is ETC, electron transport chain, and then oxidative phosphorylation to make ATP. So this is how human cells make energy. Okay, these are the first couple of reactions in glycolysis, which really is sort of primarily the 6-carbon phase. We don't need to get into this, but the second part is relevant for us with fluoride. Fluoride inhibits the enzyme enolase. Enolase is the enzyme in the second half of glycolysis, and that is inhibited by fluoride. So that's an important point. Okay, just another picture of a mitochondria showing the different spaces. The inner part is the matrix, inner mitochondrial membrane, intramembranous space, and then the outer mitochondrial membrane. This is often abbreviated OMM for outer mitochondrial membrane, intramembranous space, IMS, inner mitochondrial membrane, IMM, and then of course usually just call this a matrix. Okay, so we're not going to get into too much biochemistry, but just to have a little general idea, typically what you're doing is you're constantly pulling hydrogens off these molecules and you're splitting them into a proton and an electron. This is an oversimplification, but it tells you the key point of what's happening. So glycolysis does that. And we're basically harvesting electrons and protons to use them to make ATP. Okay, and then the same thing happens in Krebs cycle. So I just drew Krebs cycle a couple different ways. You can see the CO2 is take the carbons from the original sugars are blown off when we exhale as the form of CO2. And then the electron energy in these hydrogens split into the proton. A hydrogen molecule basically equals a proton and an electron. That is harvested off. Now, just to show you all the things fluoride does, it inhibits, 3 major enzymes in Krebs cycle. Okay, 1, 2, 3. Conatase, isocitrate dehydrogenase, succinate dehydrogenase. Okay, so it's really wreaking havoc with metabolism. This is a quick summary of what electron transport's all about. It's kind of like firemen in a bucket brigade. They transfer electrons from complex number 1 all the way down to complex number 4. And as it moves from complex to complex, the desire to grab electrons becomes stronger and stronger. Like oxygen, we showed had a very high electronegativity. It was a very strong pull for electrons. So it's just rolling downhill, these electrons. And as they roll downhill, they're used to power a pump system. And the pump takes the proton from those original, remember we talked about those original hydrogens split off from the sugar molecules, the glucose. The protons are pumped into the intramembranous space, and you build up a big gradient there. And then at the end of electron transport, you have an ATP synthase that harvests the gradient. And when that hydrogen comes back in, the proton comes back in, that energy spins this enzyme, ATP synthase, and ADP, adenosine diphosphate, is phosphorylated to ATP. ATP is the energy of the cell. That is like a $20 bill to a human. That is what ATP is. So this is how energy is made in humans. And that's about 95% of the ATP in a normal human is made that way, which is all of our energy. We make tons of it every day. Okay, so this just shows the same thing in a little bit more spread out fashion. Here's the outer mitochondrial membrane, inner mitochondrial membrane, intramembranous space, complex 1 pumping its proton, and all the other complexes. And then here's ATP synthase, adding this phosphate to the ADP to make ATP, the energy of the cell. Okay, and the reason this is relevant is fluoride will inhibit complex 4. So it's an inhibitor of mitochondrial function, of electron transport. And that becomes relevant because if you're drinking fluoridated water, you're having that happen every single day. When you drink 1 part per million, which is a common amount in fluoridated water, you're drinking about 2 milligrams per day. Adults will typically keep about half of it in their body and excrete the other half in their urine of the amount that's absorbed. And it gets more complicated because sometimes they'll increase the dose all the way up to 4 parts per million. And it's often combined with aluminum because they'll use aluminum in the water as a clarifier. Well, aluminum is a neurotoxin for the brain, so that's not good. And fluoride will bind with the aluminum, and it makes it more lipophilic, more fat-like, and that increases its ability to cross the blood-brain barrier. So as it crosses the blood-brain barrier, it can cause, over time, dysfunction to brain neurons. And lots of drugs have fluoride in them for several reasons. It can increase the half-life of the drug because it'll inhibit the liver detoxifying it, liver hydroxylation in the P450 cytochrome enzyme. So it can inhibit that and increase the half-life of the drug. It can also increase the ability of the drug to cross the blood-brain barrier. Okay, it is a waste product of aluminum production. And so, how convenient to put aluminum and F-. The aluminum companies love this into the water. Okay, and some studies do show a small reduction in dental cavities, but for that small benefit, there's a lot of other problems. I personally recommend to avoid fluoride as much as you can. Also, once an association gets committed to something, here's just some terminology if you want that. Once an association gets committed to something, it's usually hard for them to change their original position. So they won't change their opinion, the American Dental Association. Another thing is fluoride will bind to proteins and it will distort their shape. It can substitute itself for a hydrogen on the side of a protein. It especially likes to bind to these positively charged amino acid side chains, lysine, arginine, and histidine. Once it binds to the protein, it'll distort the shape of the protein. And for this reason, distortion of the protein shape, it can confuse the body. the body recognizes proteins by their shape. So if it distorts the shape of a protein on the outer surface of a cell, it can make it no longer recognizable by the immune system. And so it can become what is called a PAMP. PAMP means pathogen-associated molecular patterns. And then the immune system might attack the tissue. It can also be a DAMP, that's damage-associated molecular patterns, where damaged tissue is cleaned up by the immune system. But the real key thing here is it can cause autoimmune disease. So the relevance is if someone has an autoimmune disease, another thing they could do to try to optimize their health would be avoiding fluoride, because it might be putting them at risk for developing more of these PAMPs situations where they'll have auto antibodies form to tissue, and that can cause them some problems. Okay, F- accelerates calcification of arterial walls. I can tell you, I see tons and tons of arterial calcification all day, and it's multifactorial, primarily from atherosclerosis, but this contributes to it. It's also going to cause a lot of calcification of the ligaments in the spine, and we're going to talk about that in a moment. Collagen is the major protein in the human body. It's the glue of the human body, and fluoride interrupts collagen synthesis. And because of that, you'll get more breakdown products from collagen in the urine when a person is ingesting fluoride. Even with just as small as 1 part per million, they're going to get increased hydroxyproline and hydroxylysine in their blood. These are unique amino acids in collagen because they're initially the protein is synthesized, okay, translated. Then post-translational, you'll get hydroxylation of proline to form hydroxyproline, hydroxylation of lysine to form hydroxylysine. And fluoride is interrupting this, so it's damaging the collagen, and this can be easily detected by checking these amino acids, these unique amino acids in the urine, hydroxyproline and hydroxylysine. When you have poor collagen in arterial walls, that increases your risk of aneurysm formation. Okay, it also weakens bone. It's complex what it does to the spine. I'll get into that in a little later. Okay, so now what I'm showing is there's more mitochondrial toxins. We talked about F-, dietary fat, especially saturated fat, tends to block complex 3, cadmium, complex 3. So all these things start adding up, and that's why you want to optimize whatever you can, because there's always going to be some problems happening in the background. You want to minimize your vulnerability, your sensitivity to those problems. Okay, when F- damages mitochondrial function, that is an effect similar to what hypoxia does, what excessive saturated fat does, and this increases the risk of cancer. Okay. We talked about it, the effects of F- toxicity potentiated by albumin, and they're both in tap water. They're also both in tea, and they're sometimes both in soy. Okay, so that's worth knowing about. All right, and then this slide is called how F- toxicity happens in real life, that it's multifactorial, and you can have synergistic negative effects. So you can have the simultaneous effects of a high-fat meal, elevated uric acid, let's say from excessive alcohol ingestion or excessive high fructose corn syrup sweetened beverage will increase uric acid. The person's stressed out, they're drinking caffeine, they're sleep deprived, excessive dietary sodium, F- in their drinking water. It's also transdermally absorbed. So you shower in it, you're going to absorb that transdermally. And then there's a lot of F- in tea. Some studies show increased amounts in soy. You got a lot of F- in drugs. Then aluminum is added to the water. Then a lot of people are eating a lot of omega-6 fats with a processed food diet. That produces hydroxynonenal, the toxic aldehyde. I talked about that in a previous lecture, my dementia lecture. So what I'm saying is all these things are adding up to be harmful to brain cells, and also many of them to contribute to causing tissue hypoxia, which increases cancer risk. And not to mention these things over here, which are also have neurotoxic effects. The good news is a plant-based diet, low-fat plant-based diet helps to prevent all this because it gives you the vasodilators to reopen those arteries, the potassium and the magnesium. It gives you the vitamin C antioxidants and other antioxidants to help counter the oxidation effects, because it's an oxidant, fluoride, in that way. A lot of the researchers who research fluoride, many of them died from the toxicity of fluoride. It's pretty toxic stuff. So here's just another slide showing additional toxins and how they affect the mitochondrial transport here. So now you've got GP, glyphosate from Roundup, you got lead, you got hydroxynonenal. So all of these things start adding up. So what I'm basically saying is you want to minimize what you can. Eating organic, you can lower the cadmium a little bit, minimizing your dietary fat, especially sat fat. You'll avoid this, avoiding F- in your water, avoiding tea. These are ways to lower these things. Eating only organic avoids that. Okay, so one of the things you'll see when you read the research on its subject is when there's something that, maybe a company doesn't want you to know about, it'll be behind a paywall. You can't get the paper. So mechanism of fluoride toxicity, all I get's an abstract. We talked about disrupting collagen, easily crosses the blood-brain barrier. It also, because it's an oxidant and it damages the mitochondria, it increases reactive oxygen species. They call it ROS. It increases the incidence of Down syndrome, increases hyperactivity, attention deficit, learning disabilities in the brain, has multiple toxic effects on the brain. And you'll find it's not just one study. There's lots and lots of these studies. Here's a study coming out of China, and it shows that when this is given to children, it decreases their mental work capacity. And I see that a lot in younger people, is they just don't have the concentration. And so, you know, if you're going to do good intellectual work, you have to maintain your attention, your focus. Here's another study. The higher the F- in the water, the lower the IQs in the children. And there's study after study like this. And then, like we said, it's routinely combined with elevated aluminum in the water, and aluminum is also a brain toxin. So there's two neurotoxins affecting the brain right away just from drinking water. That's why people go, oh, you need 8 cups a day. Well, it certainly matters what you're drinking. I don't worry about 8 cups a day. I go by my thirst. Okay, if you're drinking 8 cups a day of aluminum and fluoride and estrogenics in your water, I don't think that's going to help your health. Okay, I get my hydration from just eating plant foods. They're very well hydrated, you know, fruits and vegetables and starches. Okay. All right, aluminum fluoride in rats. Let's see what this one is, you know, more of the same thing. Okay, here's the study in Mexico. Same study. You elevate fluoridated water, they get lower IQs. And babies, young children are more vulnerable because their blood-brain barrier is not formed yet. Okay, is baby formula safe? Yeah, a lot of baby formulas are toxic. It comes in an aluminum can. The aluminum itself is neurotoxic. It'll have a BPA lining on the aluminum can, and that's estrogenic. So that's an estrogen endocrine disrupting chemical. That's toxic. If it's reconstituted with F- water, hopefully they're not doing that anymore. But if it is, and they used to be, that's another neurotoxin. The corn syrup, which is used often to sweeten things, those often have mercury in them. Atrazine is what's sprayed typically in producing corn, non-organic corn, and that's highly estrogenic, so that's endocrine disrupting. The soy protein isolates, that has endocrine properties, estrogenic properties. If it's non-organic, it'll often have GP in it, which can have all kinds of harmful effects. These PUFA oils cause lipid peroxidation. They are not healthy. If omega-3 is added to it, which theoretically sounds good, but it's often extracted in that way with hexane, and soy is often processed with hexane. That's a neurotoxin. So what I'm saying is this stuff is toxic to the poor little baby's brain. Dr. McDougall has a nice newsletter on the best baby food, and he recommends the best one being this protein hydrolysate hypoallergenic cow's milk. So that's his newsletter from March. Just go to his drmcdougall.com. You can check that out. He's raised grandchildren already, so he's got a lot of experience with it. So you really want to study that carefully because, you know, give the kid a chance. If a woman could breastfeed, it would be good for her to breastfeed for at least 6 months. Okay, more toxic. We talked about that because infants don't have an adequately formed blood-brain barrier. And this article says basically it damages almost all brain structures. Okay, so that's pretty bad. All right, so I'm telling you this because it's important to get that this is not some isolated fringe thought. This is widespread, extensively documented research. All right, more research on China showing the neurotoxicity of fluoride, higher F- exposure, lower IQs. There's paper after paper after paper. Here's more of the same thing. Neurobehavioral development, the effect of high F-. It is toxic to neural development. Okay, F- in rats causes visible damage with microscope to the brain, neocortex, hippocampus, and spinal cord. Okay. F- is toxic to the brain in multiple ways and causes apoptosis, programmed cell death. It easily crosses the blood-brain barrier. That's why it's a lot of neuropsychopharmaceuticals to get the drug across the blood-brain barrier. Okay, they cross the blood-brain barrier and then it can kill neurons. This is so bad. Plants give you what you want to protect you from fluoride. They give you the antioxidants like vitamin C, for example. They give you the vasodilators to increase blood flow so you can get more of your helpful stuff, your oxygen and your healing WBCs there to help protect these cells. I think of magnesium as M for magnesium, M for mellow. It's the mellow out hormone. It also helps block the NMDA receptor for glutamate, and that's a good thing. It stabilizes that receptor so you avoid excitotoxicity types of effects. I talked about that in my dementia lecture. And this is what's so bad about fluoride. It doesn't just do one bad thing that you can prevent. It does numerous bad things. It's sort of insidious. There's no easy way to prevent this other than avoiding it. And also, like I said, living as healthy as you can and everything you can control makes your body more resilient, able to defend itself from the toxic effects of fluoride. Okay, it inhibits the K and ATPase. So that's the K is for potassium, kalium in Latin is potassium, N is for natrium, which is for sodium, and the K and ATPase. In your brain cells, your neurons, 65% of their energy is for this potassium, sodium, ATPase. So that's super important. That's the most important thing in your neuron, and fluoride's inhibiting that. So you can imagine it's not good for function. Okay, it's associated with all these eye problems too, age-related macular degeneration, cataracts, glaucoma. Tea can be a significant source of fluoride. It has a tendency to concentrate fluoride. Tea can also concentrate aluminum. Okay, so here's the American Dental Association, and the American Dental Association says they support fluoridation, as does the American Medical Association, the American Academy of Pediatrics, the World Health Organization. Okay, so my opinion is, once these organizations commit to something, they will not change their position. They're afraid of the legal implications of that. But my point of view is, when new information, that might have been a reasonable position back in 1945, 1950, but all this additional information has come out and it's well documented. I think, an individual can look at this information and say, you know what, I don't think this is a good idea. Numerous papers associating with hypothyroidism. They're both halogens, fluoride and iodine, and it disrupts the process of iodine uptake and incorporation into thyroid hormone. So and something that causes hypothyroidism, which can have this type of effect on the mother, for example, when a woman is hypothyroid during a pregnancy, the baby is more likely to be born mentally retarded. Okay, it can have a lot of significant effects. And hypothyroidism in other individuals, say an adult, cause fatigue, can cause decreased memory and other side effects as well. In communities with F- water, there's 2 times increased incidence of hypothyroidism. And from this book on how fluoride is killing you, he says, the literature is full of reports of studies of wild animals, farm animals, and humans with increased incidence of thyroid goiter when F- is present. They're exposed to F-. Okay. Like I said, some soy beverages will have a tendency to concentrate F-. Tea, even the green tea can be really high sometimes in F-. Tea can also concentrate aluminum. It can be neurotoxic. That's why I avoid tea. A lot of people think tea is a health food. I avoid the stuff. I would never drink it. Soy sometimes can concentrate these things according to some of these papers. Here's the references for all this stuff down here. We talked about tap water having aluminum and F-. Wine, grape juice, and raisins, all from grapes, can sometimes have a problem in these areas. Watch out for baking soda. It can sometimes have very high aluminum. Baking powder. Okay, effective fluoride on the central nervous system, just 1 part per million can be surprisingly toxic. And it can have a slow, insidious effect that doesn't show up for 20 years later. So it sort of weakens a person. Also, you don't want to be cooking on these Teflon things. Teflon can put the nonstick cookware, can get that fluoride into your food. Tons of fluoride in toothpaste, dental gels. You want to avoid all that stuff, the fluoridated toothpastes. Also, if you've got amalgams, previous silver-mercury fillings in your teeth, brushing with fluoridated toothpaste on them, according to this paper, increases mercury release from the amalgam. So that's not good. Another paper related saying the same thing. And then holding a cell phone to your mouth will also increase corrosion of dental amalgam. So it's better to use a speakerphone. Of course, it's a small amount, but it potentially adds up over time. So here's a study just about holding a cell phone to your mouth causing more loss of mercury from your amalgams. And here's a country, Ireland, for example, where their water is fluoridated and they also drink a lot of tea. And what the paper says is habitual tea drinking can contribute significantly to increasing fluoride and get you up over, higher levels where it becomes more dangerous. Okay, this quickly sort of summarizes some of the things we talked about. If anybody wants to look at it, I kind of have a little extra information on the word slide. So if somebody really wants to look at it more, there's more information here on some of the details. We're going to talk about the effects on bone. This is what we were talking about with collagen. Collagen is the most common protein in the body. It's like 30% of the body's protein. It's like the glue that holds the entire body together. If you bought like a model set, how to build a human, the glue would be collagen for everything. And it prevents hydroxylation of proline. So we were talking about hydroxyproline being a super common amino acid and collagen necessary to make collagen. And so when you're not getting adequate amounts of hydroxyproline into your collagen, it's non-functional. You get stiffening of joints, contributing to arthritis. It causes more wrinkling of skin, so it accelerates the aged appearance of a person. F- injury to collagen is similar in some ways to scurvy. You know, vitamin C deficiency also decreases one's ability to synthesize collagen. We talked about combination with that. Also, you know, kids have died from just a fluoride treatment in the dentist's office. If they swallow it accidentally, that can be very dangerous. You look at the container directions on fluoride toothpaste, it'll say, use only a pea-sized amount, a tiny, tiny amount. And if you swallow it, call poison control, okay? They know it's poisonous, all right? Come on. It kind of makes people sort of stupid and lazy is one of the effects, apathetic, lethargic. And I think a lot of people, I've noticed, I've been amazed in my adult life, how many people, they don't ever want to read a book. You know, they've given up on themselves. A lot of people, they're fat and they're sick and they're just like, oh, well, what are you going to do? And I'm like, well, become a vegan. That's what you should do. But they don't listen to me. Also, it can cause atrophy of pituitary. I just know from experience, I've seen tons and tons of brains, thousands of brains. It's very, very common to see atrophic pituitaries. Now, I don't know if that's from F-, but I can tell you atrophic pituitary is a common thing. It also increases the rate of calcification in the pineal gland, which is located in the brain in the midline posteriorly. And I see calcified pineal glands, you know, all the time, every day. And that is associated, they claim, these articles, with premature puberty. Okay. It also is important for making melatonin for sleep. So it can't be helping the person sleep. Damages the hippocampus, the memory center. That's not good. That's going to lower your ability to remember things and to think. When fed to pregnant animals, in this Mullenix study, it made them hyperactive, kind of sounds like ADHD. She published a big study showing all these problems with fluoride. This lady was a big researcher. I think her name was Phyllis Mullenix, and she got fired from her job for that. And that's another bad thing. And that's not uncommon when researchers publish big papers that show the negative side of something that's highly profitable for a big company. The researcher will get fired. Okay. They'll